1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6 seconds, 7 seconds, 1. Then it goes backwards. Look, I don't know. I don't know when I'm actually live, but I can see my face now, so that's nice. Well, whatever. Quadratic equation problems. So the rest of this topic, there's only 4 lessons left. The rest of this topic is all about why on earth did we even solve these in the first place? The main reason is so we can graph it, but the second main reason is to solve actual real life problems, which you might think, when the hell would a quadratic become a real life problem? You'd be surprised, actually, and it's got a lot to do with the graph, and there's a reason that this area question kind of popped up as well, and it's got to do with calculus, but yeah, kind of the underlying reason I guess won't really be known until next year, but it's kind of like area and what am I trying to say? Area and graphs are the two main applications of quadratics, and by graphs I mean graphs that are parabolic. We'll get to that in a sec, so we'll do an example of each. This area example is pretty simple, but it's what I've set up here in the top corner. It's the hardest part is setting up these questions because they don't give you a lot, and then solving it should be the easy part. So we've been solving quadratics for like almost a term now. That should be fine. It's the setting up of the problem that should, or probably is going to be the harder part. And it's where most of the marks are going to go for a question like this anyway. There's no shame in drawing it. This is a garden, and they're told us stuff about it. Draw it. Just draw it. So I'm going to draw it. It's a rectangular garden. I'm going to draw a rectangle. Obviously, it doesn't need to be to scale. It's 5 meters longer than it is wide. So it's always the terminology that's confusing. So it's 5 meters longer. So it hasn't told us anything else. So I'm going to call one of the sides x, and the other side that's 5 meters longer than that, x plus 5. I hope that makes sense. So one side is x, one side is 5 longer than x, so x plus 5. And the area, we're told, is 84 meters squared. Just also be careful that meters and meters squared lines up. If that was centimeters and meters, then some conversion needs to take place, but if not, then you're fine. Now, it simply just says find the dimensions of the garden. Now, the area is 84. But there's another expression for the area, and it's length times width. So I'll just go all out, length times width. In this case, that's x times x plus 5. Okay? So I know that x times x plus 5 is equal to 84. So therefore, x outside of x plus 5 is equal to 84. And I want the dimensions of the garden, which means at some stage I need to solve this for x. So when you're looking at this, first thing you probably want to do is expand it. X squared plus 5x equals 84. And this is the trap that I was trying to tell people about before that people fall into. And it's that people start going, okay, well, instead of doing this, maybe I'll just go, okay, well, that means x equals 84 and x plus 5 equals 84. Can't do that. So that's when I drew that big thing that was like that. Can't do that because the null factor theorem means 0. This has to have a 0 in it. If you have a quadratic equation that has 2x terms, if this wasn't there, then that's fine. You just square root. But because it's 2x terms, you have to move everything to one side and put a 0 at the end. So I'm going to move the 84. So I'm going to have x squared plus 5x minus 84 equals 0. And then you're good. So once I've got that, I can now choose how I'm going to solve this. So once I've got all my terms here, the first thing I would look for is there two numbers that add to this and times to this? 84 is quite a large number, which means it probably doesn't have that many factors. So I'm thinking 12 and 12 goes into it, doesn't it? Is it 12 and 7? 12 and 7. One has to be a minus, so 12 minus 7, is that 5? Yeah, it is. If you can think of that in your head, quadratic formula. Just as, it's probably not as fast, but you're not going to make mistakes. What did I say? X, what did I just say? Plus 12, x minus 7. Let me just check that. 12 times 7 is 84. 12 minus 7 is 5. Yeah, okay. So that means x equals, let's do this in one step. X equals minus 12 or 7. So x plus 12 equals 0, x equals minus 12. And this one is x minus 7 equals 0, x equals 7. So that's how I've got these two. Now, whenever you're looking at a real life application of a quadratic problem, there's this thing that always happens, and it's if you've got a quadratic, you're probably going to end up with two solutions. Probably not, but probably. So I've ended up with two solutions. One of them's not going to make sense. So I look at my solutions here and I say, okay, well, can my side length be 7? Cool. Yeah, it can. That could be 7 and that could be 7. Now, if it was minus 12, that would mean this is minus 12 and that's minus 12. That makes 0 sense. You can't have a rectangle that has negative lengths. Don't get me started on that. But yeah, that's kind of impossible. So what we're going to do is then you're just going to write x equals 7. So I've deleted one of the solutions, and now in brackets I'm going to say why I've deleted that, and it's because x has to be greater than 0 because it's a length. Something like that. All right, so therefore the dimensions are, now be careful because you're not done yet. Like you've found that x equals 7, but the dimensions are 7 and 7 plus 5. So that means the dimensions are 7 meters and 7 plus 5 in brackets meters, which is 7 meters by, what's 7 plus 5? 12, because we did that before. Okay, and there's a quick check you can do. So obviously the question at the start said the area was 84. If you ended up with dimensions that don't multiply to 84, then you probably made a mistake. So that's just something you can do to check. So I'll do 7 times 12, is that 84? Actually, let's just do that. So check 7 times, actually let's do meters. 7 meters times 12 meters equals 84 meters squared. Good. So I know that I'm good. So that's the area type of example. Now we're going to look at an example where it looks kind of like a parabola. And it's generally going to be something thrown, a projectile or something like that. So a ball is thrown upwards. Its height, h meters, after t seconds is given by this formula. So it's confusing because there's h's and t's. Normally you'd have like y and x and x. And you think about the y value, that's the one that's going up. And in this case, it's h. So if this was the h value, it's the height. So you kind of think of like a parabola. It's the output of this parabola is essentially how high the ball is going. So as the x goes to the right, which is like time. So because there's t's in this one, there's t's. So as time goes on, this ball gets higher and higher and higher after it's being thrown. So you imagine it's being thrown, it's kind of lobbing up, and then it comes to some point, that's terminal velocity, no, that's the maximum height, and then it starts going down, 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 down until it hits the ground. That's what this is modeling. That's all that says. What time does the ball reach a height of 24 meters? So in other words, let's say my parabola looks like this. I don't know, 24 meters might be here. At what time does it hit that? One thing to note is that you're going to get two values most probably. You're probably going to get this one and you're probably going to get this one. One other thing is if the graph looks like this, if it's purely symmetrical, and that's 24, then you're going to get this value and this value. Which one's going to make sense and which one isn't? This is time. Time is positive in this side. Time is negative in this side. So if I get some value for t being negative, that means that as I've thrown the ball, it's like, that doesn't make any sense. It's some previous time, it's now, it doesn't make sense. Just what you're probably going to find is the graph looks like this. This is going to be the height at time 0. So when time is 0, this is going to be like when it's leaving his hands, and you'll probably find that this is the height of the human being that's throwing it. And then here at time something is when the ball hits the ground. And that's also something we could find. That's just an x-intercept. I'm going way too far and beyond here. It's literally as simple as if the height is 24, what is t? Well, height is that. So h equals 30 t not squared minus 5t squared. And when the height is 24, that means 24 equals 30 t minus 5t squared. Now, again, I've got two t terms, so everything needs to move to one side. You've always got to make sure your t squared is positive, so I'm going to move all these over here. So I'm going to have 5t squared minus 30t plus 24, it's a weird 4, equals 0. And then I can start solving this. First thing I might want to check for is there a common factor so I can divide and make this monic? So make that without a term there, but I can't because that's 24. If that's 25, then maybe. But I can't, so then what I would then do is reluctantly, this is where you've got a choice to make. Do you want to go through the whole process of A times C plus B and hope that it ends up being nice? If you get to the point where you've got two sets of brackets that are different, then you're screwed and you have to restart because you'll have to use a quadratic formula. So let's just maybe start by using the quadratic formula in the first place. So I'm never confident in that method. You know, the one where you go A times C. So I just go straight to the quadratic formula. It's T equals minus B plus or minus the square root of B squared minus 4 times A times C. You'll notice that I didn't write minus 30 squared because when it squares, it's just going to be positive anyway. 2A. Okay. Now, at this point, I'd seriously just chuck it in the calculator, but I'll start simplifying. 30 plus or minus... Jesus, let me just do that square root part. 30 squared minus 4 times 5 times 24. 402. Okay. On 10. Does the square root of 420 be nice? 2 root 105, not really. Okay, at this point I'd start typing into the calculator. Now when you do that, so obviously you've got the plus or minus. So when you do that, you end up with 5.0, this is off the top of my head, 5.05 or 0.95. Okay, a quick aside, that means our parabola looks like this. At 24, so this is 24, that value is 0.9 and this value is 5.05. This means we keep both of our values. If one of these was negative, then cool. But I guess you've just got to think of this in terms of the question. You can kind of stop, if I'm going to confuse you by continuing to talk, then I'll probably stop the video here. But if this kind of makes sense, because you think of the person, let me draw it. You think of the person, he's standing here with the ball, he's got the ball in his hand, he goes to throw it, yeah, he's not 24 meters tall. So if he was 24 meters tall, the graph would look like this, and it would start, like the 24 would be like up here or something. But he's not 24 meters tall, so this picture looks kind of strange, by the way, but whatever. That means that let's suppose he's 2 meters tall. After 0.9 of a second, after he's thrown the ball, that might be about here, that could be 24 meters. Maybe he throws it 30 meters. So maybe it gets to the 30 meters, and then it comes down again, and it reaches 24 a second time. So he's thrown it, it's gone up, reached 24, it's gone a little bit higher, and then come down, and it's gone to 24 meters again. So that's why I've got two values. So after 0.9 of a second, he throws it up to 24, and then after it's reached its maximum height, it starts coming down, and after 5 seconds, it gets to 24 meters again. So that's kind of what that's saying. There's a bunch of different scenarios depending obviously on what your quadratic equation is, or your graph or whatever. But if you ended up with a negative value, that's probably going to be because, and the negative value would probably occur if it asked for a height that was less than the point at which it was thrown. So suppose like your person's standing here, if it asked when does the ball reach a height of half a meter, well, if he's standing there and it's already at he's standing there ready to throw it at 2 meters, then it would have, via the graph, reached 0.5 meters back here. So you would have gotten a negative t value, and then after maybe like 7 seconds or whatever, it would have reached the half a meter there. I really don't want to confuse people, but I feel like that's kind of interesting to the people that might want to know a little bit more about why certain values are certain values. But essentially all you really need to be able to do is, here's my height, I'll substitute into my equation and then solve it. Here, I want to know the area, so I create an equation for area and then I solve it. That's all you really need to do. But if you want to know a little bit more, that's why we have the values that we have. And I'm really passionate about this stuff because I think it's really cool, and I think that quadratic equations are disliked by a lot of people, and I think it's because people don't understand them as well as I guess you might want to. Maybe you don't want to. But I think the more you understand about why values are certain values, the more you like them and the better you are at them. So yeah, there is extension. I put New Senior Maths, which is an advanced textbook, and it has questions like this in it. And you're probably going to have t-values or time values that are negative. And try and interpret that and try and think to yourself, why would that be the case? And yeah, anyway. This is a word problem, which probably a word solution. After 0.95 seconds and 5.05 seconds, the ball had a height of 24 meters. I hope that made sense. I feel like I rambled a bit, but I think it's kind of interesting. Anyway, goodbye.